You are looking at the death of the gunpowder age. No explosions, no recoil, no debris until the target just evaporates.
And more importantly, you're looking at the death of the billion-dollar defense deficit. We are talking about a weapon that costs less than a cup of coffee to fire.
Literally $2. Compare that to a Tamir interceptor from the Iron Dome. That's $50,000 every time you push the button.
It's basic economics, Mark. If the enemy fires a $500 drone and you spend 50 grand to stop it, you might win the engagement, but you lose the war. You go bankrupt.
That's the cost asymmetry trap. But the Iron Beam flips the board. It's a 100-kilowatt class high-energy laser system. It doesn't shoot metal. It shoots light.
Which means the logistics chain just vanished. No trucks hauling missiles, no factories churning out expensive guidance chips. As long as you have electricity, you have ammo.
And that ammo travels at the speed of light. There is no lead time. There is no trajectory calculation for wind or gravity. You see it, you burn it.
This is crucial because of what's happening in Ukraine and the Red Sea right now. Cheap, mass-produced suicide drones are swarming modern militaries.
Right. The Shahed 136. It's a moped's engine strapped to a fiberglass wing. It's slow, it's loud, and it's clumsy.
But they are relentless. Russia burns through them because they are cheap. If you fire a Patriot missile worth $4 million at a $20,000 drone, the attacker is laughing at you.
It's unsustainable. I don't care how big your stockpile is. Eventually, you run out of interceptors. The Iron Beam doesn't run out. It just recharges.
That's the unlimited magazine concept. In a saturation attack, where they fire 100 rockets at once, the limitation has always been, do we have enough interceptors loaded in the tubes?
Exactly. An Iron Dome battery has about 20 interceptors ready to go. Once they're gone, the crew has to reload. That's downtime. That's a window for the enemy to kill you.
With the beam, there is no reload. It's continuous fire. But Mark, let's be real. This sounds like science fiction. Is this actually combat-ready?
It is now. Rafael Advanced Defense Systems has been testing this for years. The challenge wasn't making a laser. We've had lasers since the 60s. The challenge was atmospheric distortion.
Explain that. Why couldn't we just point a laser pointer at a missile before?
Because the air is dirty. Dust, moisture, turbulence. It scatters the beam, turning a tight focal point into a flashlight. A flashlight warms you up. A laser burns a hole through you.
So they fixed the focus. They figured out how to keep that energy tight enough to melt steel at several kilometers?
They call it adaptive optics. It's like noise-canceling headphones, but for light. The system reads the turbulence in the air and adjusts the beam in real time to keep it perfectly focused.
That changes the geopolitical calculation completely. If Israel or the US can defend a border for pennies, the strategy of overwhelming force becomes obsolete for rogue states.
It forces them to change tactics. You can't just spam cheap rockets anymore. The Iron Beam cooks them in seconds. We are talking about heating the warhead until it detonates mid-air.
Or burning off a control wing. It's surgical. But let's talk about the range. This isn't a replacement for the Arrow 3 or the Patriot, right?
No, it's a complement. Lasers have a line-of-sight issue. They can't shoot over the horizon, and they lose power over distance. We are looking at a short-range kill zone, maybe 7 to 10 kilometers.
So it sits in front of the expensive stuff. It catches the trash, the mortars, the drones, the unguided rockets, so you save the million-dollar missiles for the cruise missiles.
Precisely. It's a goalie. It clears the airspace of the cheap threats, so the Iron Dome radar isn't overwhelmed. It protects the economy as much as the civilians.
Let's dig into that $2 figure again. That price point is terrifying for arms manufacturers. If I'm Raytheon, am I worried?
You should be. If I can achieve a kinetic kill with electricity from a diesel generator, why am I buying a kinetic interceptor? The physics are just cleaner.
Clean, but hot. Managing the heat on a system like this must be a nightmare. You're pumping 100 kilowatts of directed energy. That machine has to glow.
That's the engineering hurdle. Thermal management. If you fire this thing for 10 seconds straight, You're generating enough waste heat to melt the truck it's mounted on.
So it needs massive cooling systems. That affects mobility. You can't just strap this to a Humvee and drive off.
Not yet. Currently, it's a container-sized unit. It's heavy. But in defensive warfare, like protecting a city or an airbase, mobility is secondary to sustainability.
And sustainability is where the West is losing right now. We saw it in the Red Sea. The U.S. Navy firing $2 million SM-2 missiles at Houthi drones.
That was painful to watch. A sophisticated warship wasting its limited magazine on flying lawnmowers. The iron beam on a ship deck? That solves the Red Sea crisis overnight.
It keeps the trade routes open without bankrupting the Navy. It's the ultimate zero-day economic defense. But what happens when the weather turns?
That's the Achilles heel. Heavy rain, thick fog, sandstorms. Lasers hate particles. Water droplets absorb the energy.
So if I'm the enemy, I just wait for a cloudy day? That seems like a massive tactical vulnerability.
It is. That's why you never rely on just one system. When it's raining, you use the Iron Dome. When it's clear, you save money and use the beam.
Integrated defense. But think about the psychological impact. A silent, invisible beam. You don't see it coming. Your drone just falls out of the sky.
It's terrifying for the operator. There's no smoke trail to trace back to the launch site. It's instant denial of area.
And it's scalable. Today it's 100 kilowatts. What happens when they bump that to 300 or 500?
Then you start melting tanks. You start engaging cruise missiles. We are at the Model T stage of laser weapons. This is just the beginning.
The Model T that kills for $2. This shifts the power back to wealthy, technologically advanced nations. It creates a barrier that low-tech insurgents can't afford to cross.
It forces them to get smarter, or get burned. And right now, looking at the test footage, they are getting burned. Badly.
Let's talk about the power source. You said as long as you have electricity. In a war zone, the grid is the first thing to go.
True. That's why these units have dedicated generators, massive diesel engines or battery banks. You are essentially turning fuel directly into destruction.
Which is incredibly efficient logistically. It's easier to truck in diesel than it is to truck in delicate explosive warheads.
Much safer, too. If a convoy carrying diesel gets hit, it burns. If a convoy carrying missiles gets hit, it wipes out a city block.
So we have a weapon that is safer to transport, dirt cheap to fire, and technically infinite in supply. Why hasn't this been deployed everywhere yet?
Because making it work in a lab is one thing. Making it work while being shot at, in the dust and heat of the Middle East, is another.
Reliability. Can it track multiple targets at once, or is it one at a time?
It's a beam. It has to dwell on the target. It takes a second or two to burn through, so it can't engage 50 targets instantly like a shotgun.
It has to slew. Burn, move. That's a bottleneck. If the swarm is big enough, can they overwhelm the laser's traverse speed?
Theoretically, yes. If you send 500 drones and the laser takes 2 seconds per drone, that's too slow. You need multiple beams working in a network.
A grid of light, crossfire. That sounds like a defensive perimeter that nothing survives.
That's the goal. A dome of energy. Anything that enters the zone gets cooked. It's the closest thing to a force field we have ever built.
And the financial implications for the attacker? If I know my $1 million swarm is going to be destroyed for $20, do I even bother launching it?
You hesitate, and in war, hesitation gets you killed. The iron beam changes the calculus of aggression. It makes cheap attacks expensive in terms of failure.
It's deterrence through economics. But Mark, you mentioned the dwell time. Does the material of the drone matter?
Absolutely. If they start coating drones in reflective material or heat shields, the laser has to work harder. It becomes a game of cat and mouse.
Armor versus penetration, just like tanks. But now it's mirrors versus lasers. The countermeasures are going to be fascinating.
They will try, but polishing a drone makes it expensive. And if they make the drone expensive, we've already won the economic war.
That's the checkmate. We force them to spend money they don't have. But let's look at the immediate future. When does this go live?
It's being fast-tracked. The timeline was 2025, but with the current conflicts, they are pushing prototypes into the field right now.
Trial by fire, literally. We are about to see the first real-world combat data on directed energy weapons.
And that data is going to shape the next 50 years of warfare. If this works, the era of the missile shield is over. The era of the light shield begins.
Let's move to the mechanics. I want to understand exactly what happens inside that container. How do you generate that much light without blowing up the generator?
You want to look under the hood? All right, let's break down the fiber laser technology. It's not one big laser. It's magic with mirrors.
I love magic, especially when it saves billions of dollars. Walk us through the anatomy of the beam.
It starts with rare earth elements. Ytterbium. We're going deep into the physics in the next block.
Get your safety goggles ready. We're about to focus on the mechanism.
The secret sauce here is something called Spectral Beam Combining. In the old days, we tried to build one giant, hot laser, but it was too unstable. The iron beam actually uses dozens of smaller fiber lasers, similar to the cables that carry internet to your house, but doped with ytterbium. They fire simultaneously, and a master lens merges them into a single, coherent column of destruction.
So it's the Death Star principle, multiple beams converging into one. But let's look at the supply chain for that. Ytterbium is a rare earth element, and right now, China controls about 90% of that market. If we are pivoting to laser warfare, we are trading a dependence on gunpowder for a dependence on Chinese mining. That's a massive strategic bottleneck hidden in the tech.
That's a valid concern, but the efficiency is undeniable. Once that beam is combined, it hits the target with the intensity of a blowtorch, but instantly. It doesn't push the target like a bullet. It heats the skin of the missile until the fuel inside cooks off, or the aerodynamics fail. We are essentially inducing a rapid, catastrophic structural failure by injecting pure heat.
And that cooking process disrupts the entire arms-dealing economy. Think about it. The black market thrives on selling surplus Soviet rockets or Iranian drones because they guarantee a reaction. If I sell you a weapon that gets vaporized before it crosses the border, your return on investment is zero. This technology devalues the inventory of every terrorist group in the region.
It creates a zone of denial, but the physics aren't magic. We have to talk about thermal blooming. As the laser travels through the air, it heats up the oxygen and nitrogen in its path. That hot air acts like a lens and tries to defocus the beam. The system has to measure the atmosphere thousands of times a second and distort the beam before it leaves the barrel to compensate.
That level of computing power explains why Rafael partnered with Lockheed Martin. This isn't just an Israeli project anymore. It's becoming a U.S. standard. There's a lot of money flowing from the Pentagon into this because they want this tech on American destroyers. The contract value is skyrocketing because whoever masters the atmosphere problem owns the future of defense.
Exactly. And once you solve the atmosphere, you have to solve the power. You can't plug this into a wall socket. The tactical units come with massive diesel generators or capacitor banks. When you pull the trigger, you are dumping a massive spike of voltage. It's like flash charging a Tesla in a millisecond. If that generator fails, you have a multi-million-dollar paperweight.
But logistically, diesel is everywhere. It's the blood of war. If I'm a logistics officer, I would much rather coordinate fuel trucks than coordinate the transport of explosive warheads. Missiles need climate control, security escorts, and specialized bunkers. Diesel just needs a tank. This simplifies the supply lines drastically, reducing the tail of the army.
It also removes the danger of secondary explosions at your own base. If an enemy drone hits your ammo dump, it's a disaster. If they hit your laser fuel, it's just a fire. But we have to be honest about the kill time. It takes about 4 to 5 seconds of continuous focus to burn through a steel casing. In a hypersonic war, 5 seconds is an eternity.
That's the vulnerability window. If you have a swarm of 50 drones closing in at 100 miles per hour and you need 5 seconds per kill, the math doesn't work for a single unit. That's why the cost per shot is misleading. You need to buy dozens of these units to create a wall. The initial capital expenditure is huge, even if the operating cost is low.
Correct. It's a high setup cost for low maintenance. But compare that to the alternative. A single Patriot battery costs over $1 billion. You can buy a fleet of iron beams for that price. Plus, the laser is silent. There is no sonic boom. The enemy doesn't know they are being engaged until their wing melts off. It adds a layer of psychological confusion.
Confusion creates mistakes. But I'm looking at the corruption angle. When defense costs drop to $2, the military-industrial complex loses its cash cow. There is going to be massive internal resistance from contractors who make their living selling disposable interceptors. War is a business mark, and the iron beam is bad for the recurring revenue model.
They will adapt. They'll just charge for the service and the upgrades. But on the ground, the soldier doesn't care about the profits. They care about the magazine depth. With a laser, as long as the generator runs, you never hear that terrifying click of an empty weapon. That infinite magazine is the holy grail of base defense.
It's the ultimate survival tool for a besieged outpost. But we need to address the collateral damage, or lack thereof. When a kinetic missile hits a drone over a city, shrapnel rains down. It kills civilians. Does the laser solve the falling debris problem? Or are we just trading one risk for another?
It minimizes it significantly. A kinetic impact shatters the target into thousands of pieces. A laser usually burns off a wing or destroys the engine. The drone still falls, but it falls largely intact, often without detonating the warhead in the air. It changes the debris field from a shotgun blast to a single falling object. It's much more controlled.
Controlled chaos. That's crucial for urban warfare. But there's a darker side. If we can target a drone engine with this precision, we can target anything. The potential for this to be used against personnel, blinding soldiers, or worse, is a Geneva Convention nightmare waiting to happen. The ethics of directed energy are going to get messy very fast.
The protocol is strictly anti-material right now, but you're right. The physics don't discriminate. Flesh burns faster than steel. However, the system is designed to track high-speed thermal signatures, like exhaust plumes. It's not looking for people. It's looking for heat moving at 300 knots. It's a robot hunting other robots.
For now, but software can be updated. We are stepping into an era where we trust algorithms to decide what to burn. And with the cost barrier removed, every nation, and eventually non-state actors, will want this. The blueprint is out there. How long until we see a cartel-made version of the iron beam?
High-energy lasers are hard to build in a garage. The optics require clean rooms and nanometer precision. A cartel might build a blinder, but a structural cutter like this? That's state-level engineering. The barrier to entry is technical skill, not just raw materials. That buys us some time.
Time is money. And right now, the West is buying time with technology. But let's look at the immediate aftermath. Once this is deployed fully, how does the enemy pivot? They won't just give up. They will evolve. What is the counter move to a weapon that moves at the speed of light?
They go low, and they go shiny. They will start flying drones purely at treetop level to break the line of sight, and they will coat them in mirror-finish chrome. It sounds stupid, but a polished surface can reflect 90% of the laser energy. We are going to see disco ball drones on the battlefield.
Absurd, but effective. It's a never-ending cycle. We build a light sword, they buy a mirror, but until they adapt, the iron beam is the king of the board. Let's wrap this up with the final verdict on survival and the global impact.
Let's do it. Because if you're a soldier on the ground, this light show might be the only thing keeping you alive next year.
Look at the map. South Korea is staring at thousands of artillery tubes from the north. Taiwan is facing the threat of a massive drone swarm from the mainland. The iron beam is the only scalable solution for them. If this tech matures, the threat of overwhelming numbers that dictators use to bully their neighbors evaporates. It neutralizes the quantity advantage and stabilizes the region.
It also forces a complete redesign of military architecture. For the last century, We built bunkers deep underground to hide from missiles. Now, we need high ground. We need towers to give these lasers a clear line of sight. We are going to see energy fortresses popping up, bases designed purely around generating massive power and maintaining clear 360-degree firing lines.
But this creates a terrifying reliance on automated systems. Mark, you said earlier that humans are too slow. If a hypersonic missile is inbound, a human operator cannot react in time to aim a laser. We are handing the trigger to an AI. We are giving a machine the autonomy to decide what to burn in a millisecond. That is a zero-day risk for friendly fire if the code glitches.
It's unavoidable. The UDA loop, observe, orient, decide, act, is simply too slow for a human brain against Mach 5 threats. The AI will track, lock, and fire before you even blink. The risk is real, but the alternative is getting hit. The survival tip here is simple. If you are near a defense battery, ensure your transponder is on. Do not look like a threat.
And from a macro perspective, this is the end of cheap war. For the last 20 years, insurgents used $500 rockets to bleed superpowers dry. That era is closing. If the West can shoot down cheap junk for $2, the economic attrition strategy fails. The enemy will have to go back to asymmetry, cyber warfare, terrorism, or sabotage, things that lasers can't shoot.
That's the reality. The battlefield is evolving. If you are a civilian in a conflict zone, understand this. Smoke and bad weather are your friends now. If there are lasers active, aerosol grenades or thick smoke screens degrade their power significantly. The high-tech solution has a low-tech counter. Never rely on one layer of protection. Physics always has a loophole.
My final verdict? The iron beam solves the logistics of ammunition, but it triples the logistics of energy. The next war won't be fought over ammo dumps. It will be fought over power plants and grid nodes. If you cut the cable, the laser dies. Strategic vulnerability just shifted from the magazine to the generator. Smart investors should be looking at mobile nuclear reactors next.
Agreed. It's a game changer, but it's not God mode. It buys us air superiority for pennies, but it demands perfect conditions and massive wattage. The future is bright, literally, but it's also dangerous. Keep your eyes on the sky, but don't stare at the light. Stay sharp.